Assalamualaikum warahmatullahi wabarakatuh, and hi. In this video, we are going to discuss the post-quiz exercises. So there are 2 questions for topic 1 and 5 questions for topic 2. Most of the questions are quite tough, especially for topic 2, but I believe it is something that we have to practice lah. Okay, so let's jump into it. So we have the first question for topic 1. So an equation for potential energy states U equal to mgh. So this is the equation for the gravitational potential energy. If U is in joules, with m in kg, h in m, and g is in meter per second square, find the combination of SI base units that are equivalent to joules. Okay, so we need to find the units. Okay, so this is the keyword here. We want to find the units, not the dimension. So U, okay, when you write physical quantities, use a square bracket. So U based on the equation above is equal to mgh. So in a square bracket, you can only put one physical quantity. So U is equal to mgh, where m is the mass, g is the gravitational acceleration, and h is the height. Okay, so these are the physical quantities. In terms of dimension, mass would have the dimension of mass. Okay, g would have the dimension of acceleration, which has Lt to the power of -2, where height is a length quantity, so this is L. Okay, and then multiplying them all together, we have something with the dimension of ml squared t to the power of -2. Okay, so the question asks us about the unit. Therefore, we would say that the unit is mass is in kg, length is in meter, so meter square, where time is in second, so per second square. So this is our final answer. Okay, next question for topic 1. So one equation involving force states that F net, net force, or also known as the resultant force, is equal to ma. So this equation comes from our Newton's second law. Okay, Newton's second law. So F net is in newtons, m is in kg, and a acceleration is in meter per second square. Another equation states that F is equal to negative kx. So this is the force for a spring lah. So this is a restoring force. Okay, the restoring force of the spring. Okay, where k is the spring constant, x is the elongation. So the negative sign here, so it shows that the direction of restoring force is in the opposite direction of elongation lah. Opposite direction of elongation x, elongation or compression x lah. Okay, the change in length kita. So F is in Newton, K is in kg per second square, and x is in meter. So analyze the dimension of MA and Kx to show that they are equivalent. So this is another problem of dimensional analysis. So we want to analyze MA and Qx. Okay, so let's analyze what is the dimension of MA. So for MA, so I'm writing the physical quantity. So m is the mass, so of course the dimension is mass, and acceleration is Lt to the power of -2. Okay, so we have mLt to the power of -2. Okay, so mLt to the power of -2. Whereas Kx, K and x, so it shows that there in the equation that the unit of K, the spring constant, is kg per second square. Therefore, converting it to dimension, so kg is the SI unit of mass, so that is mass. And then second is the SI unit for time, so we have mass and time to the power of -2. And x is in meter, meaning that it is in elongation, it is a length, so this is L. So we have mLt to the power of -2 as well. So we have shown here that, okay, since MA and KX both have same dimension, as shown that both have the same dimension, so we can say that they are equivalent. Okay, so that is our conclusion after finding out what is the dimension of MA and KX. Okay, now this is the first question for topic 2. Okay, in topic 2 we learn about the kinematics of linear motion. Okay, so we learn about the uniformly accelerated motion and also projectile motion. So in this question, we have a 1200 kg airplane starts from rest and move forward with a constant acceleration, a magnitude 5 meter per second square along a runway that is 250 meter long. A. How long does it take for the plane to reach a speed of 46 meter per second? And B. How far along the runway has the plane moved when it reached 46 meter per second? Okay, so in this question, we have to find the time. This is the time. Okay, let's use a different color. We have to find time, whereas for B, we want to find the displacement. Okay, so we have the mass. We have the initial velocity because the airplane start from rest, so U is equal to 0. And then we have our value of acceleration, A, and this is the length of the runway. Okay, let's name it as S. So A, how long does it take for the plane to reach a speed of 46 meters per second? So I just want to extract all the information that we have. So M is 1200 kg, our initial velocity is 0. We have an acceleration of 5 meters per second square. And then runway length, just name it as S. This is 250 meter. Okay. So for A, we want to find the time. So we have the mass, we have the UA, we have the final velocity V here. So we can use what? So V is equal to U plus AT. So our final velocity is 46. Initial velocity is 0 plus acceleration is 5 times T. So then solving for the question, we have T to be 9.2 seconds. 9.20 seconds. Okay, that is A. Then B, how far along the runway has the plane moved when it reached 46 meter? So again, 46 meter per second. So this is our final velocity. Again, we have to find the S. So for this question, since we know we have just calculated the time, the best formula for us to use would be S is equal to half U plus V times T. It's not like you cannot use another formula, but I think this is the most straightforward one. This is 0 plus 46, time taken is 9.20 second, and then we have a value of 211.60 meter. Okay. Okay, second question for the second topic. This one is fairly long. You are driving a car along a country road at a speed of 27 meter per second. So as you come over the crest of a hill, you notice a farm tractor 25 meters ahead of you on the road, moving in the same direction as you at a speed of 10 meters per second. You immediately slam on your brake and slow down with a constant acceleration of 7 meters per second square. Will you hit the tractor before you stop? How far will you travel before you stop or collide with the tractor? And if you stop, how far is the tractor in front of you when you finally stop? So there are 3 questions that you have to answer. Okay. So firstly, we talk about the car. Okay, you are driving your car. So the car initially has an initial velocity. So C is for car. Initial velocity of the car is 27 meters per second. Okay, and then distance between the car. Okay, distance between the car. Distance from car to tractor is 25 meters. Okay. And then the initial velocity of the tractor is 10 meter per second. Okay, both the car and tractor is moving in the same direction. And then the car slams on the brake and slow down with a constant acceleration of 7 meter per second square. So the acceleration of the car is negative because slow down negative 7 meter per second square. And then finally, okay, the car will stop. So we know that the final velocity of the car is equal to 0 meter per second. And we want to know whether the tractor hit the car, whether the car hit the tractor or not. Okay, that's our first task. Okay. So the first thing that we can do is we can find what's the time taken for the car to finally stop. So we have the acceleration of the car, we have the initial and final velocity of the car. So again, we can use what? So final velocity of the car is equal to initial velocity of the car plus acceleration of the car times the time taken. So 0, that's the final velocity of the car, is equal to 27, okay, plus negative 7t. So we get the time taken for the car to stop to be 3.86 seconds. Okay, and then we can find what is the displacement of the car during the period. Okay, during 3.86 seconds, how far the car has traveled. So the displacement of the car is equal to we have the time, initial and final velocity, so we can use half u plus v times t. So this is initial velocity of the car plus final velocity of the car multiplied by the time. So half plus 27, sorry, half multiplied by 27 plus 0, okay, multiplied by 3.86. So we get a value of 52.11 meter. So this is the displacement of the car. Okay. So far we have been talking about the car. And not to forget, when the car is slamming down on the brake, the tractor is still moving at a constant speed of 10 meter per second. There is zero acceleration for the truck, okay, the tractor. So let me just write it here. The acceleration of the tractor is equal to 0 meter per second square, because it doesn't say anything about slamming brake or accelerating, so we can assume that the tractor moves at a constant velocity lah. Okay, therefore the acceleration is 0. Okay, so then we can find what is the displacement of the tractor for the same period of time lah. So displacement of the tractor is equal to initial velocity of the tractor times the time plus half acceleration of the tractor times the time squared. Okay, here again I want to state that the acceleration of the tractor is equal to 0. Therefore this bit here we can cancel out, okay, because our acceleration is 0. Then substituting into our equation, the initial velocity of the tractor is equal to 10 meter per second and the time is 3.86 second. So the displacement of the tractor is 38.60 meter, okay, for the 3.86 second period. Okay, within the time duration, the truck has also moved as much as 38.6 second, 38.6 meter. So then initially the tractor is in front of the car by 25 meter. Okay, so therefore the distance for the tractor, okay, let's use a different color. Okay, tractor distance from the initial position of the car would be 38.6 meter plus 25 meter. So we get a value of 63.60 meter. Okay, so then since we know that 63.6 meter is, okay, this value here is greater than 52.11, which means that the car has not reached the tractor yet, we can conclude that the car will not hit the tractor. So therefore car won't hit the tractor. Okay, so this is the conclusion that we get. So we have answered the first question. Will you hit the tractor? The answer is no. So how far will you travel before you stop? So this is the answer, 52.11. And if you stop, how far is the tractor in front of you when you finally stop? Okay, so here we have to find the difference lah between the distance of the tractor and the car. So how far? So the distance between car and tractor would be equal to 63.60 minus 52.11. So it is 11.49 meter. Okay, so this is the third answer to the third question, right? Okay, the third question for topic 2. From the edge of a rooftop, a boy throws a stone at an angle 25 degrees above the horizontal. The stone hits the ground 4.2 seconds later, 105 meters away from the base of the building. So find the initial velocity of the stone, find the initial height from which the stone was thrown, and find the maximum height reached by the stone from the ground. Okay, let's try to draw what is happening. Okay, so let's say we have a ground and then we have a building. Okay, so this is the building. There is a stone here, and then it was thrown at an angle of 25 degrees of the horizontal. So the angle from the horizontal is 25 degrees, and then the time of flight is equal to 4.2 seconds, and then it lands 105 meters away from the base of the building. So this is our SX. Okay, horizontal displacement 105 meters. So if find the initial velocity of the stone, so we have the angle, we have the time, we have the horizontal displacement. Firstly, we need to find the initial velocity of the stone. What is the u? Okay, so remember that velocity is a vector quantity, so we have to find the magnitude and also the direction. So first one, so A, we can use our horizontal displacement to find the initial velocity. So Sx is equal to uxt, okay, and ux is equal to u cos theta, where theta is the angle of the throw, which is 25 degrees, multiplied by the time. Okay, then substituting our values, Sx is 105, u is the one that we need to find, cos 25 degrees, multiplied by the time, which is 4.2 seconds, and then we can solve for u. So u is 27.58 meter per second. Then the angle would be the same as before, 27.58 meter per second at 25 sorry at 25 degrees above the horizontal. Okay, B, find the initial height from which the stone was thrown. Okay, we want to find the initial height. Okay, so height is not like displacement. Okay, displacement is a vector quantity, so displacement can have a negative value, but height is a scalar quantity. Okay, that can only be a positive value. So sorry, B. Okay, B. So we have the time of flight. Okay, therefore we can use our type back in y direction. So sy is equal to uyt minus half gt squared. So uy would be u sine theta, and our u is 27.58. So 27.58 sine 25 degrees multiplied by the time, which is 4.2 seconds, minus half times 9 point half times 9.81. multiplied by 4.2 seconds square. So here we will have a value of negative 37.57 meter. Okay, so the negative sign because the final point, okay, the final point of the stone is lower than the initial point of the stone. Okay, but the question asks us about the height. About the height. So therefore, we can say that therefore the height, the initial height, okay, is 37.57 meters. So we can just um, remove the negative sign lah. Okay, the negative sign was talking about the final position of the stone, which is lower than the initial position. Okay, then C, find the maximum height reached by the stone from the ground. Okay, so the special information about maximum height you should always remember is that at maximum height, the y component of the velocity is equal to 0. Okay, so this is something that we should always remember lah. Okay, so for C, we are running out of space. So max height Vy is equal to 0. Therefore, we want to find Sy, which is what is the maximum height reached from the initial position of the stone. So we can use VOAS. So Vy square equal to Uy square minus 2GSy. So this is 0 square equal to 27.58 sine 25 square minus 2 times 9.81 Sy. So here we get our Sy to be 6.92 meter. Okay. So this 6.92 meter is measured from the initial position of the stone to its maximum height, which is here. So this is 6.92. But we want to find what is the height of the stone from the ground. Okay, therefore height from the ground would be equal to height of the building itself, which is 37.57 plus 6.92 meter. So we have a value of 44.94 meter. Now we are on the fourth question for topic 2. So a beanbag is thrown horizontally from a dorm room window at height h above the ground. It hits the ground a horizontal distant h from the dorm directly below the window from which it was thrown. Ignoring air resistance, find the direction of the beanbag velocity just before impact. Okay, so we want to find the direction theta. Okay, we have the horizontal h, we have the height h. Okay, we know that this is the horizontal projectile because it says here that it's thrown horizontally. Okay, so let me just draw a simple diagram for the problem. So we have the window here. Okay, and then on the window we have the beanbag. Okay, thrown horizontally so that ux is equal to u, and then our uy would be equal to 0. Then it will drop here, and then what we know is that the height is h, and then the sx is also equal to h. Okay, but then since the final point will be lower than the initial point, we can say that this is sy equal to negative h lah. Okay, sy is negative h, sx is positive h. So these are the information that we know. We want to find the direction of the beanbag velocity. So we have to find direction using the formula of theta is equal to arctangent modulus of y component over the x component. Okay, so these are the formula that we want to use. But we don't have the final and initial velocity. Sorry, we don't have the x and y component of the final velocity, so we have to find. What we know is that we have the sy, which is negative h. We have the sx, which is equal to h. We know that our ux is equal to vx, which is equal to u, and we know that our uy is equal to 0. Okay, this is because this is a horizontal projectile. Then firstly, what we can do is we can find what is our final velocity using VUAS. So vy square equal to uy square minus 2gsy. So vy square would equal to 0 square minus 2 times 9.81, and sy would be equal to negative h. Okay, therefore I can say that our vy is equal to square root of 19.62 h. Okay, as a function of h, it is square root of 19.62. And then we can look at our horizontal displacement. So sx is equal to uxt. So sx is equal to h and ux times t. Therefore, we can express t as a function of h. So t is equal to h over ux. Then, using sy equal to uyt minus half gt squared. So sy is negative h, uy is 0. So 0 minus half 9.81 t squared, where t is equal to h over ux. So this becomes h over ux squared. Okay, by simplifying, this become negative h equal to negative 4.905 h square over ux square. Okay, so then we can cross out some of the values here, some of the quantity that negative can cancel out. We have h on both sides, and then we can express ux as a function of h again. So then ux square ataupun ux terus is equal to square root of 4.905 h, and since ux is equal to vx, so this is vx as well. So vx is equal to 4.905 square root of 4.905 h. Then, so we have the y component and the x component of the final velocity. We can substitute that into our equation. So this is equal to arctangent modulus of y over x, which is square root of 19.62 h over square root of 4.905 h. Okay, so here the square root of h can be cancelled out on both the numerator and denominator, and then by pressing on our calculator we will have a value of 63.43 degrees, and then this should be below positive x-axis. Okay, so this is because actually our y value actually our y value should have a negative sign here, because when we square root the value, it can either be positive or negative. And then by looking at the diagram that I've drawn, our y component is directed downwards, so vy should be supposed to have a negative value, and I should put a negative sign here as well. But then we have the modular sign in our equation. Our angle would be always be a positive value, but then we should say about the quadrant, the specific location of the direction of the beam velocity. Okay, last question for topic 2. The baseball batter hits a long fly ball that rises to a height of 44 meters. An outfielder on the opposite team can run at 7.6 meters per second. What is the farthest the fielder can be from where the ball will land so that it is possible for him to catch the ball? So the height 44 meter would be our maximum height. So our max height would be 44 meter. Can name it as SY, 44 meter. The speed, okay, the velocity of the opposing team is 7.6 meter per second. So how far can the fielder be from where the ball lands? What is the furthest distance? So this is the displacement lah. Okay. So here what we can do is we can use VUAS. So Vy square equal to Uy square minus 2GSY. We can use this formula to find the initial velocity of the ball. Okay, this is the initial velocity using the characteristic that at maximum height. Okay, from here at maximum height, our Vy is 0. Okay, so this one would be 0 square equal to Uy square minus 2 times 9.81 and Sy is 44 meter. Okay, so Vy is 0 when the height is 44 meter lah, at its highest position. So then at Uy would be 29.38 meter per second. So this is the initial velocity in a vertical direction lah. Okay, then we can find the time taken for the ball to travel from its initial position to its maximum height using Vy. Y minus GT. Again, this is 0 and Uy is 29.38 minus 9.81 T. So we get the time, we can name it as T out, time to reach the maximum height, to be 2.99 seconds. Okay, and we know that the time of flight is equal to 2 times time to reach the maximum height, and this is 2 times 2.99 seconds. So this is 5.98 seconds. And then we can find the furthest would be the distance as is equal to ut, and u is 7.6. Time taken or the time of flight would be 5.98, and we get our displacement to be 45.45 meter. Okay, so this is the furthest that the fielder can be lah, for it to still be able to catch the ball. Okay, as a recap, okay, let's say this is our ground. Okay, the baseball field. This is the trajectory of the baseball. So our T up is up here, maximum height. The time of flight is here, time of flight. Okay, so that's the total time for the ball in the air lah. Okay, and that will conclude, okay, the exercise question for topic 1 and topic 2. Hope that you have learned something from the video. Thank you and Assalamualaikum warahmatullahi wabarakatuh.